Back grade 10s to another video. Alright, so today we're going to be covering exponents, okay, when we have pluses and minuses in between the terms. Okay, so in the previous video we were just doing multiplying, okay, same bases being multiplied, and here we're going to be dealing with examples where we've got same bases being added. Alright, so it's exciting things. I hope you guys are excited to learn. Alright, so let's jump straight into it. Okay, so what is this? Okay, so first of all, okay, before I look at this, okay, I need to first get all my prime bases. Okay, so if I look there, I've got a 5, and 25. Okay, which one is not a prime base yet? The 25. Okay, so let's just deal with that. Okay, so let's get him into a prime base. We know how to do that from our previous video. Alright, so you put that in your calculator and you get 5 squared. Okay, and over there outside of the bracket to the power of x. Okay, then plus 5 to the power of 2x plus 1 all over, okay, 5 to the power of 2x. Alright, okay, simple and simple. Okay, nothing too difficult. Alright, let's just simplify this bracket over here. Okay, so here we've got 5 to the power of 2x. Okay, x times 2 plus. Okay, so before we deal with this, okay, this is what I want to show you something quickly. Right, so if I go to a blank space, okay, and I say I want you to do this for me, x times x. Okay, what does that give you? X times x. It gives you x squared, okay? Right, but if I say 5 times 5 to the x, what does this give you? Okay, I've got same bases being multiplied. What do I do with the exponents if same bases are being multiplied? I add those exponents. So what's the exponent here? 1. Okay, so we've got 1 plus x. Right. Okay, let's try another example. If I've got 3 to the power of 2x times 3 to the power of 3, right, what's your answer going to be there? Okay, same bases being multiplied. What do? We add those exponents. Okay, so I've got 3 to the power of 2x plus 3. Alright, simple enough. Alright, so now what happens now if I give you something like this, okay, and I tell you to go back and give me an answer that looks like this? Do you guys think you'll be able to do it? Of course you can. You guys are nice and smart. Alright, so if I give you this, if I say 5 to the power of x plus 1, okay, how can this be rewritten? Okay, so can you see here, if I go from 3 to the power of 2x plus 3, all I did was I separated each term here. Okay, so I had 3 to the power of 2x, there's 3 to the power of 2x, multiplied by 3 again to the power of 3. Okay, so basically you're separating. Okay, you're separating the exponents there, okay, into your bases of 3. Okay, so let's see if we can do it here. Okay, so what's the answer going to be here if I'm going to separate? So firstly, I know I'm going to have two 5s multiplying together. Right, I'm going to have 5 and 5 because I've got two terms there. Okay, this 5 is going to get what? The x, and this 5 over here, I'm going to get the 1. Alright, so now let's check myself. Same bases being multiplied. What do I do with the exponents? You add them, okay? So I'm going to get 5 to the x plus 1. Alright, so let's try another example. So if I gave you 3 to the power of x plus 2, okay, and I want you to write it in this kind of format. How are you going to rewrite this? I want to separate. Okay, so I want to have 3 to the x times 3 to the 2. Right, hopefully that's making sense. Okay, so when I have a plus here or minus, okay, an addition or subtraction, okay, and it's not in my exponent. Can you see that this plus is not in my exponent? It's not an exponent. Okay, it's just a normal addition. Okay, when I've got a plus or a minus, okay, I want to separate all the prime bases that have exponents greater than one term. Okay, so 2 terms or more. Okay, so in this exponent here, I've got 2 terms. Okay, so I'm going to separate. Okay, so how do I separate it? Okay, so we've already done it on the next page. On the next page, we've already done examples like this. How do I separate it? Okay, I've got 5 to the 2x multiplied by 5 to the 1. Okay, 5 to the 1. Okay, so I'm going to separate it. You're going to see now why I'm separating it, okay? I'll show you now. Alright, and that's all over 5 to the 2x. Okay, how many terms do I have here? Just one term in my exponent. So am I going to separate anything? No, there's nothing to separate, so I'm going to stay there. 5 to the 2x. Alright, now let's look at the top. Okay, so how many terms do I have at the top here? I've got 2 terms. Okay, how do I determine how many terms I have? Okay, what is being separated by the plus? I've got 2 things being separated by a plus, by 1 plus. Okay, so I've got 2 terms. Okay, multiply does not separate terms. Okay, so this is one whole term. All right, so if I look at this term, okay, and I look at this whole term, all right, is there anything in this green box and this green box that looks exactly the same? Anything that looks exactly the same? Okay, can you see that there's a 5 to the 2x and 5 to the 2x in both green boxes? Okay, so when I see something that's the same, what do? What do we do in previous examples? Factorizing. Okay, we took it out as a common factor. Awesome. So there's a common factor of 5 to the power of 2x. Okay, so how do I do that? Okay, so I'm going to take it out. Okay, so I've got 5 to the power of 2x as a common factor, and I open up a bracket. Alright, so if I take out a 5 to the 2x in this green box, what's left in that green box? Nothing. Okay, when there's nothing left, it's always 1. Alright, are you happy? Alright, so I can say 5 to the power of 2x times 1 gives me 5 to the power of 2x. Do you guys see that? That's why it's 1. Okay, now I'm separated, these green boxes are separated with what? A plus. So I'm going to put a plus. Right? Then in this green box over here, if I take out a 5 to the 2x, what's left in this green box? Please tell me. Just a 5 to the power of 1. Yes, there's a 1 left here, but it's 1 times 5, which is just 5. Okay, so you don't have to say 1 times 5. All right. So we know that's just 5. All right. And then everything is over 5 to the 2x. Right, now how many terms do I have at the top? I've got 1 term. If you don't know that that's 1 term, go watch my previous videos. Alright, and how many terms do I have at the bottom? 1 term. So can I cancel things that look exactly the same? Of course I can. Okay, is there anything here that looks exactly the same? Yes, the 5 to the 2x's look exactly the same, so I can cancel those out. Okay, they divide and they give you 1. Right, and what is 1 plus 5? 6. Alright, so easy peasy. Alright, so how do I know, what's the clue, okay, that I'm going to have to take out a common factor? Right, so in the previous video we had multipliers here. There was no common factor, there was none of that. Alright, but how do I know now that I have to take out a common factor somewhere and that I have to separate and all those things? How do I know that? What's my clue? This plus or the minus. Okay, so some examples will have a minus, some examples will have a plus. So that's your clue, guys. Okay, so NB that, right? That's your clue. Now you know. Okay, if I see a plus, okay, immediately I'm going to separate all my exponents, okay, that have more than 1 term. Okay, this has 2 terms. I'm going to separate, right? Then once I've separated, I look at these things that look exactly the same, take it out as a common factor. There we go. Right, and what's left in the bracket, okay, and then eventually you're going to cancel stuff, and then you simplify the bracket and you get your answer. Okay, I hope that makes sense. All right, so let's go straight to the next example. If you want to rewatch this section, just stop the video, rewind, and just rewatch it. Okay, right, next example here. Okay, so what is this? Okay, so first thing I always check before I even start. Okay, I need to check something first. I need to check for prime bases. Okay, are all my bases prime numbers? There's a 2, there's a 2, there's a 2. Okay, are all those 2 prime bases? Yes, they are. Fantastic. All right, so I don't have to change anything. I don't have to put anything in my calculator. Okay, but I see something that's a clue to me. Okay, I see a positive there, right? Can you see that that's not an exponent plus? Okay, that's a normal plus. Okay, there's no exponent there. Okay, so I see a plus. So what are you guys thinking in your brains? You're going to do? You're going to separate. You're going to separate these exponents because there's two terms. You're going to separate, and then what are you going to do? You're going to get a common factor. Okay, then things are going to cancel. Okay, then I'm going to get my answer. Okay, so let's see. Okay, first thing I'm going to separate. So let's separate this over here. So we've got 2 to the power of x times 2 to the power of 1. Separated. Okay, awesome. Plus, I'm separated with a plus there. Plus 2x all over. Right, at the bottom I also have two terms, more than one term in my exponent. So what am I going to do there? I'm going to separate. Fantastic. Okay, separate. Separate. Right, now I've separated everything. Okay, now I look at the term that has the plus in it. Okay, look where it is. There's the plus. Right, and I look at my two terms that I have here. Here's my first term. Okay, and here's my second term. Okay, is there anything that is common? Anything that's exactly the same in both of those terms? Anything that you see there? Good. Okay, can you see that the 2 to the power of x is in both of those terms? So they're in both terms. I'm going to take it out. Okay, take it out as a common factor. Open up a bracket. And if I take out a 2 to the power of x in this green box, this term over here, right? What is left in that green box? There's a 2. Okay, so you've got 1 times 2, which is just 2. Okay, so I know a lot of students, they say 1 times 2, but you don't have to write that 1 because 1 times 2 is just 2. All right, then we separate it with a plus, right? And if I take out a 2 to the power of x in this box, what is left there? There's nothing. And when there's nothing left, it's always 1. All right, now I can check myself. 2 to the power of x times 2 is 2 to the power of x times 2. 2 to the power of x times 1 is 2 to the power of x. Alright, so that's factorized properly. Right, all over. Right, 2 to the power of x times 2 to the power of 2. Right, are there anything in the denominator and the numerator that look exactly the same? Yes, can you see that the 2 to the x and 2 to the x are exactly the same there? Can you see that? Okay, why can I cancel them? I can. Why? Because there's one term at the top, one term at the bottom. All right, so I can cancel those. Right, and what is left at the top? We've got 2 plus 1, which is 3. All over, what is 2 to the power of 2? 4. Fantastic. All right, I hope it's starting to get in your brains now. I hope you're starting to get it. All right, please rewatch the video if you're still not understanding. Okay, let's go straight to the next example. All right, let's stay fresh and funky. All right, so pause the video, see if you can do this example by yourself before you do it with me. All right, so let's look at this. All right, so I look at all my bases. Okay, all the bases that have exponents. Okay, that I'm going to be working with. Okay, so I look there. There's a 2 there. Okay, there's a 5. Fantastic. There's a 2. There's a 2. They're all prime. They're all prime numbers. All right, fantastic. All right. So, what do I see there? I see something. I see a clue. I see that there's a minus now. Okay, so when I see a minus, okay, so alarm bells should be going off in your brain. Ding, 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 ding. All right. What am I going to do immediately in my mind? I know I'm going to separate. Okay. Then after I separate, I always get common factor. After the common factor, they cancel. Things cancel and I get my answer, simplify brackets and so on and so forth. Okay, so let's see. Let's go through the process. Right, so here I've got 2 to the power of 2x. All right, minus 5 times. Okay, I'm only going to separate this one because 5 is just to the power of 1. There's no 2 terms there, so 5 just stays there. All right, then we've got 2 to the power of 2x. Separate times 2 to the power of 1. Right, all over. Beautiful. Let's separate this nicely. Okay, 2 to the power of 2x times 2 to the power of negative 2. Right, can you see it's a negative 2? Don't make it positive if it's negative. Keep it negative. Keep it there. Right, We're going to deal with it later. Alright, so now let's see. Look at the top where the minus is. There's the minus. Alright, so I look at my first term. There's my first term. Right, and I look at my second term. Okay, my second term is quite large. Okay, there's 3 things in there. Alright, so now I ask myself, okay, is there anything inside these 2 green boxes that are exactly the same? Exactly the same. It's the 2 to the power of 2x. 2 to the power of 2x. Can you guys see that? Okay, if you can't see that, please open your eyes. There's no ways you cannot see that. Alright, so I see that they're exactly the same. So I'm going to take it out. 2 to the power of 2x. Right, I open up a bracket. Boom. Right, if I take out a 2 to the power of x, 2 to the power of 2x in this box over here, what's left? Eyeball, there's nothing left there. Alright, so when there's nothing left, it's a 1. Alright, 1 minus. Okay, so if I take out a 2 to the power of 2x in this bracket over here, I take it out. Alright, what's left in this green box? Okay, there's a 2 and there's a 5. Can you see that? I've got 5 times 2. So 5 dot 2. Right, 5 times 2. That dot just means multiply. Okay, close your bracket. Okay, I hope that makes sense. Right, all over. Right, 2 to the power of 2x times 2 to the power of negative 2. We're going to deal with this just now. Don't worry. Deal with it now. Alright, and over here. Now I'm going to cancel things. I've got my bracket. I'm going to cancel now. Anything that looks exactly the same in the top and the bottom. Yes, 2 to the power of 2x, 2 to the power of 2x. Alright, so here I've got 1 minus 5 times 2. Okay, so what am I going to do first? The minus or the multiply? I'm going to do the multiply first. Okay, so if you look at BODMAS, we've got brackets of, division, multiply, addition, and subtraction. Okay, so BODMAS. Okay, BODMAS is still a thing. Alright, so brackets of, division, multiply, addition, and subtraction. Okay, so multiplication comes before subtraction. Okay, so I'm going to multiply first. Okay, so what is 5 times 2? It's 10. Good. Alright, so here at the top I've got 1 minus 10 all over. What's left at the bottom? 2 to the power of negative 2. Don't worry about it. I'm still going to deal with them. Okay. So, what's 1 minus 10? Negative 9. Okay. Now, let's deal with this 2 over here. This 2 to the negative 2. When I've got something to the negative power, and I want positive exponents, I'm telling you, I want positive exponents. Okay, for this question. What must I do with this 2 to the power of negative 2? I must take it to the top. Okay, once I take it to the top, it's multiplied by 2 to the power of positive 2. Right, and at the bottom, what's left at the bottom? 1. Okay, now let's simplify a little bit. Okay, we've got negative 9 multiplied by 4 over 1, which is just this. Okay, so the 1 doesn't matter about the 1 anymore. And what is negative 9 times 4? Negative 36. Alright, hoping that makes sense. Okay, it's a nice example. Right, if you don't understand anything still, maybe just rewind, go back, look at the example again. Okay. Alright, moving on to the last example for today. Okay, so last example for today, just pause the video, see if you can do it by yourself, and then watch the video again and see if you can do it with me. Alright, so I assume you've done it already. You paused the video, you've done it. Alright, so I see something immediately. What do I see? There's my clue. Okay, what is that? That's a subtraction. Okay, so immediately alarm bells. Ding, 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 ding. Alright, what am I thinking? What's my process? I know I'm going to separate, separate, separate. Okay, then I'm going to get, eventually I'm going to get common factor. After common factor, things are going to cancel, simplify brackets. Alright, answer. Alright, let's see if we can go through the process. Okay, so we've got 3 to the power of 3x times 3 to the power of 1 minus 2 times 3 to the power of 3x times 3 to the power of negative 1. Alright, all over 3 to the power of 3x times 3 to the power of negative 1. Right, fantastic. Now I've separated, boom, boom, separated this one, boom, boom, and I've separated the bottom, boom, boom. Right, now I look at the top where my minus is. Okay, there's my minus. You see it? Okay, same minus. Now I look at each of those terms. Okay, so let me highlight it for you. There's my first term, and there's my second term. Okay, in my first term and my second term, is there anything that looks exactly the same? Exactly the same, guys. Exactly the same. Anything. Okay, can you see that 3 to the power of 3x, 3 to the power of 3x are exactly the same? It's the only thing that's exactly the same. This is 3 to the power of 1. That's 3 to the negative 1. So it's not the same. Okay, there's no 2 in this box here. So exactly the same is 3 to the power of 3x and 3 to the power of 3x. Okay, so I can take it out. Okay, whoops, let me change my color here. Okay, so I've got 3 to the power of 3x as my common factor. Right, open up my bracket. If I take out 3 to the 3x in this bracket, in this box over here, what's left in this green box? Just a 3 to the power of 1. Okay, so 1 times 3 to the power of 1, which is just 3. Minus, if I take out a 3 to the power of 3 here, right, what's left in this green box? There's a 2 and there's a 3 to the negative 1. All right, please, guys, just look at what's left in the box. Okay, so here we've got 3 minus a 2 times, okay, 3 to the negative 1. Right, and that is all over 3 to the 3x multiplied by 3 to the negative 1. Alrighty. Okay, now I've got my bracket. Cool, I've got one term at the top, one term at the bottom. Is there anything here, alright, that I can cancel? Yes, the 3 to the 3x's. They look exactly the same. I can cancel those. Alright, so let's go here to the top. Alright, and we've got 3 minus 2 times 3 to the negative 1. Alright, so this 3 to the negative 1, I can't take it down because I've got two terms. Okay, so at the top there, I've got 3 minus 2 times 3 to the negative 1 at the moment. Okay, all over 3 to the negative 1. Okay, so I've got two terms at the top now. Okay, because this 3 to the 3x cancelled. Okay, so the brackets fall away, and I've got two terms now at the top. Okay, so I can't just cancel here or take this down and take it up yet. Okay, I need to simplify this at the top first. Okay, so I've got 3 minus 2 times, how can I rewrite 3 to the negative 1? Okay, so when we had x to the power of negative 1, what did that equal? Okay, 1 over x. Okay, 5 to the negative 1 is 1 over 5. Alright, so 3 to the negative 1 is 1 over 3. Alright, so going back here. Alright, so 3 to the power of negative 1 is 1 over 3. Right, so 2 times multiplied by 1 over 3. Okay, all over 3 to the negative 1. I'll deal with him later. Okay. Alright, so we've got 3 minus, what is 2 times a third? That's 2 over 3. Good. Alright, and that is all over 3 to the negative 1. Okay. Now, we've got 3 minus 2 over 3, and what does that give you? Okay, it's going to be 7 over 3. Good. Okay, so 7 over 3. Okay, I'm going to rewrite this quickly. Okay, so this divide, okay, I'm going to write it as divide. Okay, what am I dividing by? 3 to the negative 1. 3 to the negative 1. Okay, so all I did was I just wrote this in a different format, because otherwise I'd have fractions over fractions and it doesn't look very nice, doesn't look neat, people get confused. Alright, so I just simplified here at the top, got 7 over 3. Okay, divided by 3 to the negative 1. 3 to the negative 1. Okay, so it's just a different format, so don't get confused here. Right, and I've got 7 over 3 divided by, how can I rewrite 3 to the negative 1 as a positive exponent? It's 1 over 3. Right, so now what do I do when I'm dividing fractions? I multiply and flip. Good, so 7 over 3 multiplied by 3 over 1. Okay, so I'm busy multiplying here, so these 3's will cancel, right, and I'm left with 7. Okay, so equals 7. Okay, or you could have said 21 over 3, which is 7. So top, top, bottom, bottom. We've got 7 times 3, which is 21. 3 times 1, which is 3. Okay, so we write it in here. It's 21 over 3, which is 7. Okay, alright, grade 10s, I hope this video finds you well. Alright, I hope it helps you with your preparation for your exams and your tests. Yeah, so the first thing that you guys always need to look out for is this clue over here, to notice what you are doing. Okay, so always look ahead, see if you can look ahead in the future. There's a minus or a plus. Alright, then we're going to separate. Okay, common factor, cancel, alright, and simplify. Right, it's always the same thing, guys, always the same thing. Find the pattern, adapt, and get your answer. Right.